Hi, calculus class, and welcome to chapter 3. This one is all about limits and derivatives and slopes and tangents and all kinds of fun things. So we're actually finally getting into calculus and some of the stuff that you'll need to know, especially when you get to college. So, my glasses, I got a glare on them. Let's try this. All right, so let's do well. And make sure you got chapter 3 notes in front of you, and let's move. Okay, the first section is the whole chapter is about derivatives, which you're going to love. They are so fun and they make a lot of things a lot easier when we're finding speeds and velocities and things like this. But today it's just limits. So we're looking at functions of limits, if it exists, rules for limits, and infinity limits. Okay, a limit is how it reacts when you approach from the left and from the right. So right here, we are approaching from the left. So as we approach from the left, and that's written, I'm approaching 2 from the left. This is what this means. Okay, that's what the negative is, from the left. So as you watch, as you plug in 1.99, 1.999, 999, and it just keeps getting larger and larger and larger, closer to 2, your number here gets closer and closer to 4. So we're going to say the limit as x approaches from the left is 4. And over here, it's from the right. So we go 2.1, 2.01, 2.001. So we're getting closer and closer to just 2. All right, if you look, this in here gets closer and closer to just 4. So the limit from the right, which is written with a plus sign, is 4. Since these two limits are the same, the limit of the function at 2 is 4. It actually doesn't matter what the value of 2 is. Okay, let's look at this from the graph standpoint. This is actually x squared is what we were using. So I have x squared is f of x. So if you look from here, as we are approaching from the left, this here goes up and approaches 4, the value of y. As you approach from the right, so you're going down, it is also approaching 4. It doesn't actually matter what that value is. It's what it is approaching. If it equals 4, that's nice. That's called continuity. If it doesn't, it's discontinuous, but it still has a limit. All right, and that's what these words are right here. They're just saying as you get closer and closer to the value from the left and from the right, if it equals the same number, L, then it has a limit. If it doesn't equal the same number, it does not have a limit, and it may or may not equal the L. So it doesn't actually have to have a value at that side. Okay, here's another one. We're going to do this first, the table method. So I'm going to plug 1.9, 999, 999, and just keep going. And I know to use 2 here because that's where it's undefined. So I know x cannot be equal to 2 because that's one of our critical points. Remember when we were graphing these? So I'm going to do one. So I'm going to approach from the left. And as I am approaching from the left, so this is written, the limit as x approaches 2 from the left of f of x is equal to 4 this time. Now we're going to approach from the right. So the limit as x approaches 2 from the right, so that's the plus sign, of f of x. Again, as you look, it's also approaching 4. Since these two limits are the same, the limit of the entire function is 4. Okay, this actually, that's on decimals, which is fine. Okay, so if you look here, again, we have our parabola. Let's do this algebraically. So we factor out the x squared, the x minus 2 cancels, and I am dealing with x squared. That's where this parabola came from. So we draw in the x squared parabola, right? But it does not have a value at 2, so there's an open hole because that's division by 0. Again, when you look at it, as you approach from the left, it's approaching 4. As you approach from the right, it is approaching 4. Even though there is no value of 4 on the graph, the limit as x approaches 2 is 4. Okay, try yours. Again, you should have noticed that x minus 2 is where this thing is undefined, so x cannot be equal to 2, which is why we have our limit here. Now, when you find your limit as x approaches 2, we're going to take and factor this. X plus 2, x minus 2 over x minus 2 cannot be equal to 2 because we're taking that out, and we're really finding the limit as x approaches 2 of x plus 2. All right, so let's just draw this to make sure we know what we're doing. Plus 2, there's my y-intercept. It's got a slope of 1, and there's my line this time. At x equals 2, there is no value. So what happens as the limit x approaches 2 from the left of x plus 2? Well, as you look, as it approaches 2, if we plugged in 2, we would get 4. And it does. It continually approaches 2, 4. So this limit is 4. Now let's try it from the other side. The limit as x approaches 2 from the right of x plus 2. So again, now we're coming down. Again, if you plug in the 2, you're going to get 4. The limits are the same. Therefore, the limit of this function is 4, even though it has no value at 2. Okay, piecewise functions. So now I've got x squared. I'm going to tell you that it can't have a value at 2 just because I decided. All right, so there's no value at 2. So at 2, I'm going to put an open circle. But at 2, I'm going to give it a weird value, and I want it to be 1. All right, now let's look what happens. I'm going to do the limit as x approaches 2 from the left of h of x. Well, when you look, as it is approaching, it is still approaching 4. And the limit as x approaches 2 from the right of h of x. So now we're going down, it is still approaching 4. I understand that h of 2 is actually 1, but my limit is 4 because that is what I am approaching. It doesn't matter that this equals 1. Okay, pause and try yours. Okay, this time the problem was 3. So now we're going to do the limit as x approaches 3 from the left of f of x. Well, this time when I plug in 3, I'm going to get 2 times 3 minus 1, which is equal to 5. And we know this is a line. It's got a y-intercept of -1, slope of 2. So our line looks like this. And at 3, it is 5, which it cannot be. So it's actually 1. So when we do this, it's going to approach 5 from the left. If you look, the limit of f of x as x approaches 3 from the right is also 5. Therefore, the limit as x approaches 3 of f of x is equal to 5, even though the true value is 1. Does not matter. It matters what it approaches. Okay, we also have some variables when it does not exist. So let's see if we remember this dude. Let's graph him first because I think that will help. Remember our vertical, you set the denominator equal to 0. Subtract 4, divide by 2, so x equals -2. And there's my vertical. Your horizontal, remember, was most important, so 3x over 2x, which equals 3/2 or 1.5. And there's my horizontal. And then we'd have to plug in 1 on each side, so we'd have to plug in a -1 and a -3. And if we plug in -1, we get -3 plus 2 over -2 plus 4, so -1/2. And that is going, there we go. And if we plug in the -3, we're going to get -9 plus 2 over -6 plus 4, positive. Okay, so this guy goes this way. Now let's look what happens. So now as x approaches from the left, right here, we get positive infinity. Because look, it's going up and up and up and up. It just continues. It will never hit there, but it goes on forever. Now let's look as a limit as it approaches -2 from the right. Well, if you look at -2 from the right, it's going down forever, so that's actually negative infinity. These two are not the same, therefore there is no limit. Technically, even if they were both infinity, there would still be no limit. What we would write, the limit equals infinity, to explain what's going on, to give us more information. But a limit does not technically exist. All right, try yours. I love this one. Okay, let's see how you did on the graph. All right, so I know x cannot be equal to 0, so this is where it's undefined. Now, if I plug in numbers, just for fun, if I plug in 1, so I'm really saying the absolute value of 1 over 1. Well, that's 1, right? Let's plug in 2. Absolute value of 2 over 2. Here, I'm actually doing a table. We should probably do this over here. Let's start with -2. -1, 0, 1, 2. Okay, so we're doing the absolute value of -2 over -2. Well, that equals -1. Absolute value of -1 over -1. Again, -1. All right, and at 0, we know it's undefined. So this is -1 until I get to 0. So the limit as x approaches 0 from the left of the absolute value of x over x is -1. Now what is it at +1? Well, the absolute value of 1 over 1 equals 1. The absolute value of 2 over 2 equals 2. Just to get a feel for the graph, you could do the little numbers, the 0.99, the 0.999, 0.099, the 0.0099, all the way through. Either way, you're always going to get 1. Well, if you look, so that the limit as x approaches 0 from the right is also going to be 1. These do not match. Therefore, there is no limit. Not even infinity. It just does not exist. All right, so this is what it's telling you. If it becomes increasingly large or increasingly small, we say it's a limit of positive infinity or negative infinity. If it approaches a number, then that's the limit that it is. If it does not approach a number, then it does not exist. All right, so let's go down here and look at these rules. Right here, we're going to look here first. This one here approaches positive infinity from the left and negative infinity from the right, so it does not exist. Okay, if you look here, right here at this section, it approaches -4, and this one here, I'm sorry, approaches 3. I said that wrong. As it approaches -4, it equals 3 at this point, but 2 at this point. Since 2 and 3 are not the same, it does not exist. Here, it approaches 3.5 from this side and 3.5 from this side. So then the limit does exist, and it's 3.4. My fault. 3.4. This one here, it goes down and approaches negative infinity. And then on the other side, it also approaches negative infinity. So we write the limit is negative infinity. Technically, it still does not exist because there's no number to go to. So, but we still write this to give us information. All right, so what do you get here? What do we get when we approach 4? From the left and from the right, we are approaching 1. So the limit is 1. Here, as you're approaching 6, it approaches 2 from the left and from the right, so then the limit is 2. I hope that picture helps you get all your different things in line. Okay, these are the rules for limits, and they're kind of self-explanatory, and I never make you write the rule down. I just want to make sure you understand them. Okay, we got two functions, and the limit of f is a, and the limit of g is b. If you're taking a constant, then the limit is equal to the constant, okay? And if I'm taking a constant times a function, then I can take this constant out and just find the limit of the function times the constant. Makes it a little easier. If I am adding two limits, I can take the limit of the first plus the limit of the second, or subtract. If I am multiplying two functions, I can take the limit of the first times the limit of the second. I don't have to do them all out. Same with division. I can do them together or separate them out, whichever is easier. Okay, If p of x is a polynomial, then the limit of the polynomial is what it is when you plug in a. So that means it doesn't have anything weird. That's why our x squareds always came out to be what they were. Okay, for any real number k, now this one's kind of nice. If I have a function, f of x to the k power, I can take the limit of the function, right, this limit, and then take it to the k power. Sometimes that's easier. Okay, if the limit of f of x equals the limit of g of x, then f of x must equal g of x. These are the two that are truly helpful. If I'm taking the limit of a number to a function, so like 3 to the 4x plus 7, I can take the limit of 4x plus 7 and then take b to that power. This makes life easier. The same is true with logs. I can take the limit of the inside function first and take the value of the log second. Those are all helpful things to use. All right, we're going to use them on here. Okay, I'm going to tell you the limit as x approaches 2 is 3 of f of x, and as of g of x as x approaches 2 is 4. So we have x approaches 2 of 5x plus our f of x plus 5g of x. So the first thing we do is we break this apart. So we take the limit of the first plus the limit of the second. Well, the 5 is still in the way, but I know the limit of a constant is itself. So we bring the 5 out front. Now we can do this as a simple math problem. This one here is 3 plus 5 times 4, which gives you 23 is your limit. Okay, let's go here. So here's got a couple. So I've got a power and I've got a natural log. So I can do the limit of each of them individually, which is what I want to do. Now I don't want to square the function first because that's too hard. So I'm going to take the limit of the function and then square it. Very different. So the limit of f of x is, my page, 3. So this is going to be 3 squared in the numerator. Now, I don't want to take the natural log first. So I'm going to bring the natural log out and take the limit of g of x, because that's what I know. So now I'm going to take the natural log of 4 in the denominator. Type that in your calculator, and you should get approximately 6.49. Okay, this one here. This one is a little difficult because they want me to square it first and then take the limit of it, which I don't know. But I can take the limit as x approaches 2 of f of x plus g of x, and then take that answer and square it, and it gives me the same thing. Well, next I have to separate out my limits, right? So the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. And I'm going to take that answer and square it. So now I have the limit of f of x is 3. The limit of g of x is 4. Square that. 7 squared is 49. So the limit of this function is 49. Not too bad so far, right? Okay, let's do this one. I want to know what the limit is. X approaches 3. So first thing we're going to do is break this thing up into 2 pieces. So let's do the limit as x approaches 3 of x squared minus x minus 1 over the limit as x approaches 3 of the square root of x plus 1. Okay, next, we know that we can break apart these limits. So this is the limit as x approaches 3 of x squared minus the limit of x approaches 3 of x minus the limit as x approaches 3 of 1. All over. Now let's break this up. This is really to the 1/2 power. So we're going to take the square root and we're going to move the limit inside. The limit as x approaches 3 of x plus 1. Now since those are all polynomials, I can plug in my numbers and I'm going to get 9 for this one minus 3 minus 1. Remember the limit of a constant is itself, all over the square root of the limit of x plus 4 would, or x plus 1 would be 4. So now we have 5 over 2 is our limit of our function. Kind of fun, right? All right, this time we have to be careful because if I let it 0, it's undefined, or let it be 2, it's undefined. So we have to do a few other things. So the first thing we're going to do as x approaches 2 is we're going to factor the top. So let's do x plus 3 and x minus 2 all over x minus 2. Well, now I know these two are going to cancel, so I'm really finding the limit as x approaches 2 of x plus 3. I know it's undefined at 2, so it will never equal this, but the limit will equal this. Now we plug in our 2, and we get 2 plus 3, which is 5. So the limit of this function is 5. Okay, let's keep going. This was kind of fun to graph on decimals first, just so you kind of see what it's doing. So if you had decimals out, do that. But let's look at this. This thing is really interesting. So we have the limit as x approaches 4. I know it can't be equal to 4 because that's 0. But I have this square root of x minus 2, and I can't do anything with that. Well, since I can't do anything with it, I'm going to try to get rid of it to see if it will help me out. So I'm going to do that by using a conjugate. But remember, whatever I do to the numerator, I have to do to the denominator. Well, if I do that, whoops, I was supposed to say limit. Here we go. Maybe. There we go. All right, so now we've got the limit as x approaches 4. On the top, I'm going to have x minus 4. Whoops. I'm getting ahead of myself here. I don't have time to do that. So this becomes x minus 4, right? Square to square, x minus 4 all over. I'm not going to multiply this out because I see that it's going to cancel. So this goes away. So now I'm looking for the limit of 1 over the square root of x plus 2. I'm going to plug in my 4. I get 1 over the square root of 4 plus 2, which is, we know, 1/4. So the limit of this function is 1/4. Okay, pause and try yours. First thing we're going to do is see if this thing cancels. And we know it cannot be equal to 1 because that's where it's undefined. X cannot equal 1. It's undefined. All right, so now we got the limit as x approaches 1. This is x minus 1 and x minus 1 all over x minus 1 cubed. Well, when I do that, I get 1 over x minus 1. This is an issue. Since this is an issue and it's undefined at 1, this one here has no limit. I'm hoping you remember what this looks like, right? So if we set this denominator equal to 0, we get x equals 1. And we do 1 over x for our horizontal, which is 0 because we have x, whoops, sorry. Said horizontal and drew vertical. It's been a long day already. Okay, let's try this again. All right, so then we know this goes here. When we plug in our values, it goes here and here. So as you approach 1, it approaches a negative infinity and a positive infinity. Therefore, there's no limit. All right, here we're just reading from a graph. So you should be looking at science. The pond has 12 units of dissolved oxygen. Waste was introduced to the pond. That formula represents the amount of oxygen in water T weeks later. So what is oxygen level after 2 weeks? So let's go to 2 weeks, and I've got right here, roughly, what is that, 6? Okay, so after 2 weeks, it's 6. After 8 weeks, let's go up here. That's about 10. After an infinite amount of time, so we know that this thing is going on and on forever, it's going to approach 12, but it will never equal 12. So the limit as t approaches, infinity is going to be 12. All right, because it's going to go on forever. So f of t. Now, let's go down here. All right, if you have x of n in the denominator and it approaches infinity, it's 0. And if you have negative infinity, it is 0. So let's see what we got here. This here is the function above. Now, it started off as the 12t squared minus 15t plus 12 all over t squared plus 1. Okay, and we couldn't do that. So what we do is we divide everybody by t squared, because technically that doesn't change it a lot. So if we divide everybody by t squared and we function as t approaches 0, this here cancels. This is 1 over t, t squared, t squared, t squared. So we're using this here rule right here. So as we plug it in, the limit of this guy is 0. The limit of this one is 0. The limit of this one is 0. And the limit of this one, I'm sorry, this is 1. And the limit of this one is 0. So we get 12 is our limit. Okay, let's try a more fun one. Okay, do yours. Let's see how you do. First thing you should have done is divide by x, because this is approaching infinity. So you have 8x over x plus 6 over x plus 3x over x minus 1 over x. So these cancel. These are x's in the denominator, so this is x plus 0 over 3 minus 0. So your answer is 8/3. Okay, do all the rest of yours. Let's see how you do. So now we're dividing by x cubed. So we have 3x over x cubed plus 2 over x cubed, 4x cubed over x cubed minus 1 over x cubed. Okay, this is going to cancel. This here still has a squared, still in the denominator. So this is 0 plus 0 over 4 minus 0, which is 0. This one here, 3x squared divided by x plus 2 over x. And we have 4x over x minus 3 over x. Cancels. This one here still has an x in the numerator. When you plug in, so now you've really got 3x plus 0 over 4 minus 0. This still has an x in the numerator, which means it is infinity. So technically it does not exist. But we are going to write infinity so we understand what's happening. So don't forget, even though it does not exist, you still want to write infinity. Okay, next one. Should be divided by x squared. So now we have 5x squared over x squared minus 4x cubed over x squared all over 3x squared over x squared plus 2x over x squared minus 1 over x squared. All right, first one cancels to 5 minus 4x over 3 plus 0 plus 0. Again, a 0 in this here, but it's negative. So this one here approaches negative infinity. Technically does not exist. Good luck on your homework. Remember to post your questions.